For our homework tonight, we're going to be practicing using the segment addition postulate. So in our first example here, we're going to use that postulate to find PR. So remember, the segment addition postulate essentially says this: if I have any segment, okay, so let's say it's called AB, and I divide it up into AC and AB, the length of AC, so AC, plus the length of CB is equal to the length of the entire segment AB. Okay, so this is what we're basing everything that we do today off of. So looking at this first one, they've given us PR. They said that PR is 9, and then they say that the distance between Q and R is 15. We're going to use this information not to find PR, because they've already given us that. I meant to write PQ. Okay, so we're going to find PQ. Well, 9 plus whatever this number is should give me 15. So I can do one of a couple things. I could say 9 plus x equals 15 and subtract 9 from both sides and find that x equals 6. Or we could just say that the whole 15 take away 9 will leave us with a remainder of 6. So either way you do it, you're going to find that the length of QP is 6. So we would say QP equals 6 or PQ equals 6. Okay, in this next example, I'm going to say that point X is the midpoint of segment AB. So let's go ahead and draw our segment AB. And X is the midpoint. Now remember, a midpoint is important because it divides our segment into two equal parts. So that means that AX is congruent to XB. And we use this little tick mark to represent that AX and XB are congruent. So these lengths are exactly the same. This is the same as that. Now I'm going to tell you that XB is 22, and we need to find the length of AB. So AB represents the entire length. Well, remember what we said. If X is the midpoint, it divides AX and XB into two equal parts. Remember, that's what these little tick marks mean. They mean that they're congruent, they're equal. So if XB is 22, AX must also equal 22. Together, AB is just 22 plus 22, which gives us AB equals 44. So that's our final answer, AB equals 44. Let's look at another problem that has midpoint. So in this case, point X is the midpoint of segment PQ. So we'll label P and Q. X is the midpoint, so it's somewhere in the center, and we're going to show it's the midpoint by writing these little tick marks saying that PX is congruent to XQ. Now what if they said this? Let's say they told us that PQ was equal to 30, and they want us to find PX. Well, if we know that PQ is equal to 30, how could we find PX? Well, we said that PX and XQ, these are congruent, aren't they? So whatever 30 is divided by 2 would give us this value. So you could think about it a couple ways. Let's say this is A, this also is A. Therefore, A plus A equals 30, or 2A equals 30. A would be 15, right? If you don't want to do it algebraically like that with a variable, you could just think, well, I know that the whole is 30. If I cut it in half, that gives me my value for PX, which is 15. So either way you want to do it, PX is equal to 15 for our final answer. In our next example, we're given a figure, segment AB, with C somewhere in between, and then they say that AC is x plus 5, and then CB is 3x plus 3, and then the total distance between A and B is 36. So we're going to use this information to find CB. Okay, find CB. So eventually we want to find this length right here. So the segment addition postulate says that a segment is equal to the sum of its parts. So we need to set up an equation. So we're going to start with AC. So if AC is equal to x plus 5, then I'm just going to write x plus 5 plus the next part, 3x plus 3. So plus 3x plus 3 equals the entire length of the segment, which in this case is 36, equals 36. So in order to find CB, we're going to use the segment addition postulate to set up an equation like we did. We're going to find x, and then we'll be able to plug x in to find the length of CB. So we got to do a little bit of algebra. I have x plus 3x gives us 4x plus 5 plus 3, which is 8, equals 36. And then a little flashback to algebra here, subtract 8. Divide both sides by 4. Our x is equal to 7. Now, x is not the answer. Remember, you always need to look at what it's actually asking you to find. If this was the concept test and you wrote x equals 7 as the answer, you did the right work, but you didn't actually answer the question. You need to read the questions and interpret what it's saying. They want to know CB. So CB is this 3x plus 3. So we can take that 3x plus 3 and use the fact that x equals 7 to plug it in. So we have 3 times 7 plus 3. 21 plus 3 leaves us with 24. So CB is actually going to be a length of 24. There's our final answer. In this example, we have ray TW, so ray TW, bisects segment SU at T, and then we're going to find ST. So first, let's break down what this term bisects means, because a segment bisector could be a ray, a point, a segment, a line. It's something that cuts a segment in half into 2 equal segments. So even though my picture is not drawn very perfectly, and it may not look like it's cutting it in half, if it tells us that it bisects the segment SU, then that means that ST right here is going to be exactly the same length as TU here. Again, the picture may not be drawn to scale, just like mine is not. Eventually, they want us to find the length of ST. Well, ST has a variable in it, so it tells me we're going to have to do a little bit of algebra. So let's use what we know. One thing we could do if we're looking at segment addition postulate is think about how the 2 parts together equal a whole. That would be great if I knew the entire length SU, but we don't know anything about that. So we're actually going to rely on what we know about bisectors. If this cuts SU in half, then that means that ST is exactly the same as TU. We can use our algebraic expressions to create an equation with that. So ST, or 2x plus 2, is going to be equal to TU, or 5x minus 10. This is an equation that we can use to solve for x. So let's do a little bit of algebra. It's a good refresher if you don't remember doing this. So we have 12 is equal to 3x. Divide both sides by 3. And we're going to find that x is equal to 4. That is awesome, but that's not the answer. They want us to take it a step further and find ST. So remember, ST was 2x plus 2. So we're going to use our x value. So 2x plus 2. We're going to use x equals 4 to plug in. So 2 times 4 plus 2 leaves us with 8 plus 2. So ST is equal to 10. Let's say that they took this one step further and now they want to know what the length of SU is. So SU would be the entire segment. Well, if we know that ST is 10 and TU is congruent to that, that's also 10, we could then add that together and find that the length of SU is going to be just double 10 or 20.